It's time for our autonomous access points to go on a diet. By the end of this session, we will be able to describe lightweight access point design. Lightweight or thin access points use the same hardware as an autonomous access point, but they run a lighter version of the software, meaning that they can't make a lot of their own decisions. They have to be told what to do. In this video, we're going to explore lightweight access points and see how they solve a lot of the problems that we saw in the last video. We're going to solve a lot of the problems of autonomous design by introducing this concept of lightweight access points. The idea of lightweight is this. We're going to have access points that must be fully controlled by a controller. This means that they get their configuration from the controller. This means they get their software from the controller. They are not able to do anything without communicating with a controller. So if I were to take a lightweight access point home and plug it into my home network, it's not going to be able to connect to the controller, and therefore it won't be able to do anything for me on my home network. The way this works is a wireless access point is going to connect into the network and power on, and it's immediately going to DHCP an IP address. Once it gets the IP address, we're going to pass an option to it so that it knows where the wireless LAN controller is. It's going to reach out to that wireless LAN controller, or WLC, and download not only the software package that it needs, but also the configuration. Anytime an access point boots, if it needs a software revision, it will download that software. So already we've solved a major problem that we had with autonomous access points, and that is standardization of the software and configuration. Now another problem is solved because this wireless LAN controller is my management point. Therefore, I now have a single pane of glass to manage all of the access points in my network. Now I say that, but that might not always be the case. For example, if I have 5 wireless LAN controllers in my environment, then that's 5 different interfaces I have to log into and configure. Therefore, in a lot of cases, we'll have management software that sits above the wireless LAN controllers, and that allows us to configure everything from a single pane of glass. In a future skill, we're going to cover Cisco's Software-Defined Access, or SDA. SDA brings the management of all of the wireless LAN controllers and the entire wireless infrastructure under a single umbrella we call DNA Center. But more on that later. So what about those networking problems that we talked about in the last video? Well, what's interesting is that when a lightweight access point connects to the network, they are actually going to tunnel their traffic all the way to that wireless LAN controller. So let's say that we have a wireless LAN controller on the network here in my data center, and I have that same topology that we saw in the last video where we've got this layer 3 boundary happening. And so when we have this scenario where we have access points on 2 different switches that are part of separate layer 2 domains, well, how do we handle this situation of layer 3 roaming? Well, this tunnel is going to help us do that. We're going to send all of our control plane and data plane information in a tunnel that we call the Control and Provisioning of Wireless Access Point Protocol, otherwise known as CAPWAP. So when I say we're going to send our control plane and our data plane information, here's what I mean. The control plane is all of the control information, so telling the access point how to behave, here's your configuration, should you turn up or down your radios. But the data plane is actually the wireless client traffic. So when I boot up my wireless device and I connect to the wireless network, well, my traffic is no longer going to be dropped off on the switch like an autonomous access point. Instead, it's going to be directed into the tunnel, and it will get tunneled all the way up to the wireless LAN controller. And because of this, I'm part of the layer 2 domain where the wireless LAN controller exists. In other words, from a logical perspective, it looks like my client is connected to the wireless LAN controller. This means that if I have another client attached to a wireless access point at a different location as part of a different layer 2 domain, we're going to have the exact same situation, where this traffic will get put into a tunnel and sent through the network, and it will look as if I am attached to the wireless LAN controller. Now this has benefits and downsides. The benefit is that we are now part of the same layer 2 domain wherever in the network I am. It doesn't matter whether I'm attached to the access point on the left or the access point on the right. And therefore, when I roam from one to the other, I can keep my IP address. That is an immense benefit to lightweight access points and tunneling our wireless clients to the wireless LAN controller. Now here's the downside. I mentioned that this wireless LAN controller is in our data center. Well, our data center is where our apps and our data lives. It's a very mission critical part of our network. And what did I just draw on this diagram? Well, I just said that our wireless clients are part of the data center network now, and that is not exactly ideal. So we have to be very careful about where we deploy the wireless LAN controller. Putting it inside the data center might not actually be what we want. For example, a lot of organizations will have a firewall sitting between their users and their data center to keep bad traffic out. For example, if my laptop attaches to the network and it's got malware on it, it might try to reach out to the data center and see if it can break into any servers. And this is exactly why we deploy this firewall. However, look at the diagram we just made. If indeed the wireless traffic is getting sent into a tunnel and it's showing up on the wireless LAN controller, then we have just completely bypassed this firewall. This is why, again, we have to be very careful where our wireless LAN controllers get deployed inside of our networks. Now that said, just because we have to be careful about deploying wireless LAN controllers doesn't mean that this is a bad solution by any stretch. In fact, lightweight access points are exactly what we want to deploy into the modern network. There are a lot of different benefits that we get from this. First and foremost, we are able to manage a lot of different access points from a single controller, and potentially from software that can manage the controllers for us. So it gives us a single pane of glass management for our entire wireless network. Second of all, we have the benefit of standardizing our software and our configurations. Third, we no longer need to worry about layer 3 roaming. And then on top of all of these benefits, we also get other benefits. The wireless LAN controllers can enable the self-healing of wireless networks, such that if one access point has a problem, it can boost the other access points in the area to make up for that one access point, because the wireless LAN controller has a global view of the wireless network, not just the view from a single access point. And second of all, location services are often tied to lightweight design. Again, because of that global view, a wireless LAN controller can enable us to find wireless clients and pinpoint their locations, and maybe even track historically where wireless clients go over time. And we're going to talk more about location services in a future video. So in the end, the benefits of lightweight design far outweigh any of the downsides that we might encounter. We just need to do one of two things. Either we need to be very careful about where we put the wireless LAN controllers, or we do have in many cases the option of disabling this concept of tunneling the traffic through for our wireless clients. So we're going to cover all of this in more detail in the next video. And with that, you're able to describe lightweight access point design. I hope this has been informative for you, and I'd like to thank you for viewing.